The angle of the prism is A and one of its refracting surface is silvered. Light rays falling at an angle 2A on the first surface return through the same path after suffering reflection at the second surface, the silvered surface. The refractive index of the prism is. First of all, assume that there is a prism and this prism has an angle A, and this is the normal at the first surface, and this surface is silvered. Okay, let this be equal to BC. So over here the surface AC is silvered. The first ray is incident at an angle of 2A. So over here it will get refracted once, and then it will return to its original path. If it returns to its original path, let us concentrate on the surface AC for the time being. The incident ray after reflection, if it follows the same path, it means that the angle of incidence and the angle of reflection is 0. Okay, the angle of incidence and the angle of the reflection over here is equal to 0. Then only I can say that the incident ray and the reflected ray will overlap each other. Okay, so over here can I say the incident ray is and the reflected ray both are same. So I can say that the angle of incidence and the angle of refraction is equal to 0. So I can say the ray itself is normal over here. Okay, the ray itself is normal over here. So I can say that this angle over here is equal to 90 degree. Okay, this angle over here is equal to 90 degree. This angle is A. So this angle will be equal to 90 minus A. Okay, this angle will be equal to 90 minus A. So the angle made with the normal, that is the angle of refraction over here will be equal to 90 minus A, which will again be equal to A. So the angle of incidence is equal to 2A and the angle of refraction is equal to A. We have to find out the refractive index. Refractive index over here will be equal to sin I divided by sin R, which is equal to mu over here will be equal to sin 2A divided by sin A. So sin 2A will be equal to 2 sin A cos A divided by sin A is equal to mu. So basically over here sin A will get cancelled out. Over here we have to find out the refractive index. So the refractive index will be equal to 2 cos A, which is equal to option number B.